Welcome back, boys and girls. So in this video, we are going to move on to the last subtopic in topic 1. We have 1.4, charge in a uniform electric field. But before we consider the motion of charge in uniform electric field, we have to understand what is meant by uniform electric field. So, uniform electric field can be produced by two flat parallel metal plates which is charged. One is positive and one is negatively charged. So one plate is positively charged, one plate is negatively charged, and is separated by a distance d. For example, this plate is charged positive 100 volt. This plate is being charged, negatively charged, negative 100 volt. Okay, so then we will create a uniform electric field in between the two parallel plates. So a uniform electric field is represented by a set of electric field lines which are straight and parallel to each other and equally spaced. It must be equally spaced. Why? Because we say the electric field is uniform. So the directions of uniform E is same as concept for point charge. The direction of uniform E will run from positive plate to the negative plate. So konsep dia masih sama macam point charge. So electric field line akan keluar daripada plate positif pergi masuk ke plate negatif. Okay? So this one is what we call uniform electric field. So what is the relationship between the uniform electric field E with the potential difference delta V? So the relationship between uniform electric field produced by two parallel plates separated by a distance d and the potential difference is given by E equal to negative delta V over D. Delta V represents the potential difference, D represents the separation between the plates. Okay, so sometimes the delta V over D also called as potential gradient. The negative sign indicates that the value of electric potential is always decreases in the direction of electric field. Okay, for example, the positive plate here is 100 volt. In the direction of electric field, the value of potential is decreasing. 75, 50 volt, 25 volt, and here is 0 volt. So you can see obviously the electric potential decreases in the direction of electric field. That's why we have a negative in the relationship. So if we plot the graph, electric potential against distance, so we will find out that the potential gradient will be negative. Okay, it will be negative. From this relation, we can calculate the magnitude of electric field for uniform electric field, whereby the magnitude for uniform electric field is given by delta V, the potential difference between the two plates, divided by the separation between the two plates. Okay, so dalam kiraan nilai electric field untuk two parallel plate, kita tak perlu consider negatif lah sebab kita nak kira magnitude sahaja. Kita nak kira magnitude sahaja. Okay? So, be careful. This equation is only can be used for uniform electric field, E, such as in capacitor. Okay? So, formula ni hanya boleh digunakan untuk uniform electric field. For point charge, contohnya charge positif ataupun charge negatif. For point charge, Untuk point charge, we cannot use this equation. For point charge, yang kita belajar sebelum ni, for point charge, the electric field must be calculated using E equal to KQ over R squared, whereby the electric field produced by the point charge is non-uniform. Okay? So, electric field produced by point charge is non-uniform and we must calculate using KQ over R squared. This equation is only valid for uniform electric field. This equation. And then, since we said it's a uniform field, it means that the field strength is same at all point, class. At all point. At any point inside the parallel plate, the value of electric field strength is the same. So, electric field strength point A is equal to electric field strength point B is equal to electric field strength point D and also electric field strength point C. Why? Because it's uniform. Uniform means constant. The value is not changed. Apa yang beza ialah potential difference. The potential difference, okay? The value of electric potential decreases in the direction of electric field. So, yang beza adalah potential. So, potential point A will be greater than potential point B, will be greater than potential point D and greater than potential point C. So, potential will be different, but the electric field strength is the same. Clear? So, class, how we are going to use this equation? So, let's say I give you a parallel plate and I said that the plate is having a potential difference of 300 volt and the separation between the plate is 2 centimeter. So, how I'm going to find the electric field strength created by this parallel plate? So, the electric field strength will be delta V over D. So, I'm going to have 300 volt divided by the separation is 2 centimeter change to meter times 10 negative 2 meter. So, I'm going to have, so the electric field strength for these two parallel plates will be 15,000 volt meter minus 1. Okay, the unit will be volt per meter. So, on the next video, we are going to continue with the motion of charge in uniform electric field.